Hi, it's Jan Beta, and we're going to build an open source arcade-like joystick today. The joystick we're going to build today is part of the open source arcade stick project by Frank Niggemann, who was kind enough to send me all the bits and pieces and little parts that I have already spread out here to build the Commodore 64 version of this project, which has all kinds of bells and whistles, and I'm super excited about this. This video is going to be in English as usual on my channel, but if you are a native German speaker, you can also check out the website linked in the video description for the OSA stick, and then go to references, and there's a bunch of German language videos about assembling this joystick, and also some good blog posts and tests of the finished product, so you might want to check that out if you're not into listening to my German accented English. The finished product is not going to be too dissimilar from this one that I built from a trash-picked metal box here. It's going to have adjustable auto fire just like mine, regular fire buttons, auto fire buttons. That's basically the same layout that this open joystick that we're going to build is going to have, but these are cheap arcade replica parts basically that I used here, and the project we're building today is going to have a better joystick and lit buttons. So here's all we need to assemble this. 3D printed parts which are openly available on the website in a Git repository, and this is constantly evolving still. This is pretty early on in the project, but this is the first released version of this joystick basically, and there's plans for compatibility with more systems, and the community around this is also pretty active in working out some quirks and making this a better product. Even though it's a free product, it's still a product, I guess. These parts here are the heart of the operation. That's the actual stick that we're going to assemble, and that is pretty versatile in that it can fit in this enclosure or other enclosures, and you can also fit this in arcade cabinets and things like that. There's screw holes to fit this in everything basically, screwed through from the top. This is going to screw in from the bottom here, as we're going to see. This version uses a nice DE9 cable, of course, because that's the connector for the Atari compatible joysticks that the Commodore 64 and other computers also used. Comes with different shapes of sticks that we can use, and of course you can also modify the STL files that are offered to your liking. This uses micro switches for the stick. These are the ones that have these little rollers here, but otherwise they are just like the micro switches you would find in, for example, the Competition Pro joysticks of the time or the Zip Stick. They all use pretty similar micro switches. These are the ones with the little rollers. There is a bill of materials on the website, so it should be relatively easy to find all these parts. Frank sent me all of this, as I said, so I didn't have to bother with that too much and can't tell you good sources for these materials. But there's a bomb. There's also a Discord with the community that is very helpful. So if you want to build your own, there's always people that are friendly and helpful. So this is a kind of an interesting part. This is a bearing that is 3D movable. That's where our stick is going to sit in. And there's also a new solution now. There is a 3D printed solution that uses like a soft 3D print material like TPU, which works in a similar way to the older Competition Pros with the rubber ring to hold the stick. And there's just an aluminum tube fed in here. That's a tube on purpose to make it possible to run wires through here in case you want to have a fire button here, maybe, on top of the stick. So that's an 8mm aluminum tube, or aluminium if you prefer. If you get these for cheap, they are probably going to be a bit wonky in that they don't move smoothly, so we might have to work on that a bit. A whole bunch of screws and screw inserts, and also some rubber feet that screw on. These are all just M3 parts, I think, so nothing too fancy. Should be relatively easy to get these. We have these fire buttons, which actually have the ability to light up. That's one of the nice features of this. You need, of course, several lengths of wire to wire all the switches and buttons up. We have a little circuit board for an autofire circuit. That's going to be a controllable autofire. And we have a switch, just a slider that is going to make it possible to switch the lighting modes of this. And you can also just use buttons that are not lit. This is designed to be modular as well as customizable to whatever you prefer. I think I already mentioned that I'm pretty excited about this whole project. This is exactly up my alley, just assembling one of these. It seems to be very well thought through at this point already, and as I said, it is constantly evolving still. I think I have all the parts. I'm going to add parts from my parts bin in case I need them. Let's start to assemble this thing and see how it goes. So I think the first step we should do is to put some screw inserts into this top part of the shell. And these are melt-in inserts, 8 of them. And these work in a way that you heat them up. These are little brass inserts. You can heat these up. There are specialized tools for that, but a soldering iron is going to be fine. You heat these up and press them down into the posts here. I'm not exactly sure which material this is. I think PETG probably, or ABS, or PLA. You can print this in whatever material you prefer. Given that these are meant to be printed on a filament printer, you are going to have a material that melts at certain temperatures. I'm going to heat up the soldering iron, probably not to the full soldering temperature, but to something like 200 degrees Celsius to not be too destructive. And then we have 2 other inserts here. And these are riveted inserts. Maybe we have to heat these up too. But yeah, let's do these first. And of course, in case I forgot to mention it earlier, thank you, Frank, for sending me this and letting me build this and try this out. So, soldering iron is heated up to 200 degrees. Going to place these as straight as I can, and then I'm going to heat them up. And they should eventually move down. There we go. That's a bit deep, but we're going to be okay. And these should be super solid after the plastics cool. And as I said, there's specialized tools for this, but you don't really need them if you're just doing this occasionally. Yeah, I think that's these ones in place. This one I went a bit too far, but it should be fine because the screws are longer than needed, so we should still be able to grip that, and probably that's even a better grip than the other ones. These are going to go in here and are going to protrude a tiny little bit, but that's going to be okay. I'm just going to hold them straight, heat them up a bit and put them in there. Push them in there. Yeah, there we go. There we go. And these are protruding here a bit, but they fit the cutouts on this, so no problem whatsoever. So let us assemble this stick part, which consists of this plate and the other plate. And this goes on top here. We need some regular nuts in here. And of course, we need the micro switches in here. These are all M3 standard nuts and M3 screws. And these have cutouts here that should fit the nuts. And these are just going to be tightened, of course, and then sit in there very sturdily. Yeah, as you can probably tell already from the number of points of screws here, this is going to be a very solid construction. Much more so than the replica arcade parts that you can buy. Now these grip into each other, and we can put the longer screws in there. There's only 2 lengths of these that you need. The short ones are 12mm screws, M3, and the longer ones are 20mm screws. So we need the longer ones, of course, to be able to reach through here. And we need a little hex screwdriver here. 2mm hex is what these are. So I'm just going to screw these in here, I think. Yeah, these 4 holes here are just for when you want to mount this in another case. We don't need these for this build. Also a nice feature that the micro switches are actually held in with 2 screws. They always have 2 screw holes in this form factor, but for example in the Competition Pro they were only held in with 1 screw, at least the ones I have. And one failure mode that occurred quite often was that these got slightly dislocated. So that is better design in this one. So now we can place these in here. Yeah, and now we should be able to screw the screws in fully. And we should be able to reach the nuts on the other side. That's pretty satisfying. This part on the bottom here, that goes on the stick in the bottom. I just realized that there's actually an insert for a nut on the inside of this as well. So we have to put a nut in there and then we can put one of our set screws in there. And I'm just using one of the 2mm screws to get the nut in there, which is probably the easiest way to achieve that. Yeah, I'm just going to try to push that a bit with another pair of pliers here. There we go. That's in now. Okay. And these are 1.5mm approximately. At least this fits. We'll see. Yep, that fits fine. Yeah, that's how it's supposed to be. The height of this centered on these. That's pretty much that. It just sits against this thing. That should be the correct height. So on these set screws, should be tightened now. So there's 2 of these set screws on this bearing. And this goes in here. Yeah, that's how it's supposed to go. This is at the exact center of where the little rollers from the micro switches are. And now we can screw this part in. Test fit. Yep, that's how it's supposed to go. Yeah, this all fits really well. So these are the 1.2 centimeter or 12mm screws here. Now there's the button choice, I guess. That's probably the next step. And of course the option for the stick itself, but I'm not going to put that on yet. So we have yellow buttons, 2 of each of these colors, white and red. I think the white ones and the red ones. I think these bottom ones are going to be the regular fire buttons. I definitely want to go red with these just because the original Competition Pro had red buttons there. And the other ones, I think white is going to look pretty cool. And of course, if you are building one of these, you can have whatever colors you like, or whatever colors are available. So these have little clips that actually fit in these indentations here, so they are going to sit pretty solidly in here. It's starting to look like a thing. Yeah, these sit in here pretty nicely. So white ones for here. Yeah, I think that looks good. This is what it looks like now. I have the contacts facing each other, which might not be the best idea. We have to fit an autofire circuit in here. Yeah, I think that's actually the next step, building the autofire circuit. There's also an autofire circuit with surface mount components in the works, I think, so this is going to be a bit smaller in the next version of this, or in the alternative version. Yeah, this is just some basic soldering. And this 555 is of course socketed although I've seen very few of these break. Yeah, this is relatively straightforward. 2 resistors, capacitor, another capacitor, some pin headers, so we can connect this nicely. Let's solder this up quickly. The resistors, 2 of them are both 1 kilo ohm, and the other components just fit in the places, except for this, which goes on the wire. These pin headers just fit in, one with 3 pins and one with 2 pins. The electrolytic capacitor has a minus on one side that goes into the minus labeled side. Just going to take my 555 here out of the socket for soldering, because we don't want that to overheat. This is a very beginner-friendly circuit board. This should be easy if you know how to hold a soldering iron, basically. So we can place our timer chip in there. Of course, there's a little notch on the chip, and there's a little notch on the silk screen on the PCB, and there's a little notch on the socket, which we are all going to line up. So, and that's our little autofire circuit, adjustable autofire. Going to clean this up with some circuit board cleaner, and then we can continue our journey. Haha, we put the switch in the wrong way around. Okay, this is exactly the kind of thing that I would do. Of course, the switch goes in this indentation here. And this is the backside of the joystick. So we're going to have to screw that down again. From the other side, this time. And also, yeah, it is pretty obvious, but I didn't see. That's the kind of thing that I do wrong all the time. At least I didn't advertise this as a tutorial. Yeah, that's clearly the way this is supposed to go. Sorry. The other part of the adjustable autofire, of course, is this adjustable potentiometer, which is a B5K, a linear 5 kilo ohms pot. So that goes in this hole here and is going to be screwed in. But I don't think I'm going to screw it in just yet, because we can easily put that in from the backside after we have figured out the wiring, which is the next step. And that's going to be the most involved one, I think. So this is the part where it's going to get a bit messy, presumably. This is the wiring diagram that's also on the website. Of course, there it is in color with colored connections. And we have to do quite a bit of wiring if we want the switch and the autofire in there. The thing I want to start with is to make the connections for ground, which is going to all the switches, the directional switches, and our regular fire buttons. And the ground for these is going to go through our little PCB, because these are the autofire buttons. We need ground for the LED lights as well, so that's going to be fun. I'm going to use crimp connectors for these switches, the micro switches. I don't have the right size for these fire buttons, so we're just going to solder on the wires there. I'm not going to go into much detail about this. Basically, you have to just follow the wiring diagram yourselves. Ideally, you use crimp connectors for all these connections. These are going to be pin header connectors. I have crimp connectors for those, for the 555 autofire. So yeah, let's see how it goes. There are several crimp connections where you have to connect more than one wire in one crimp connector, but that's going to be relatively easy if you just count these connections here. These protruding little things on the micro switches are what's switched between these two. There's the switch. So these are going to be connected to the number, the pin on the DE9 connector. Yeah, let's see how that goes. Lots of wiring to be done. Okay, let's do this. So, ideally, we have all our ground connections for the regular ground that's not going through the little circuit board there. Both our normal fire buttons are connected to ground, and all our 4 directional switches are connected to ground. I bent some of these tabs a bit, which is completely doable. They still make good contact, hopefully, to fit the wiring better in here. And yeah, these crimp connectors I have are super crap, so if you have the chance, get some better ones. These are the insulated type. I don't really like these for things like that. They are super handy for power supplies and things like that, but you want the uninsulated ones. They're probably easier to crimp for small wires like this. Yeah, I'm just going to go through the whole wiring diagram and make the connections necessary, basically. These lit switches actually have one side labeled as minus, it's this one in this case, and one as plus. And of course that doesn't make any difference for the actual switch part, because that's just closing these 2 contacts here. But for the LED it's going to be super important which side you wire up to which. So if you get the polarity wrong, the LED is of course not going to light up. Just wanted to point that out. That's actually marked on the switches. Next up is the 5-volt rail coming from the device that the joystick plugs into. And that of course powers our 555 autofire circuit and the LEDs. So we have to connect all the LEDs to this and our circuit board. Yay! So that's our positive voltage rail. Next up are the connections for one side of all the fire buttons, which are going to be connected to pin 6 on our connector. And that's just another one that connects through to all the fire buttons. That's one side of the fire button, and the other side is going to be the ground. For the regular fire buttons, the ground is just permanently hooked up, and for the others, it's hooked up through the switch to our autofire. So that is going to be pulled to ground by the autofire circuit if that is activated. And this green wire here is going to go to the other end of the autofire buttons and through a diode to the switch, through a diode to our 555 PCB. Now the other end of our LED for the regular fire buttons. That's brown in the circuit diagram. And I'm going to use yellow wire because that's the closest match. And finally, the one that's dark purple in the circuit diagram, which is just dotted black, crudely dotted black in this, because I ran out of colors, is the negative connection to the autofire buttons. To be quite honest, I am a bit confused already, but we're going to see how it goes. That should be all our connections inside here that are not facing towards the outside world. The connections on the micro switches are all going to be connected to our cable that's connected to the device we want to use this with. For this autofire thing, I think I'm just going to use these standoffs that have this double stick foam on the back side here and plug into these mounting holes. These are 3mm mounting holes, and then I'm just going to find a position where this sits nicely, and I guess that's going to be fine. So these things just clip in like so. They are very similar to these awful standoffs that old PC cases had. So I think it should be totally feasible to put this here with these double stick feet, and just going to have to measure the distance between here and here, but then it sits like here. And there's just enough room for everything. I'm just going to try that on. Let's see if that fits. Yeah, that's going to be fine. Nice. Okay. So connections to the rest, the switch and this little board. Turns out I made the connections for my grounds here on the micro switches in the wrong spot. At least 3 of the 4. But that was immediately corrected after I posted pictures of this state in the Discord for the project. So thank you for your help. I have now corrected this. You have to connect the contact closest to this side contact here. And then this is going to close whenever the switch is actuated with this side contact here, which is going to go to our cable. The next step is going to be connecting this switch assembly here, and I'm going to use some cutoff wires from components to make these connections for the ground on the switch, and we're going to have to place the diode in, and we're going to have to connect this with the 555 board. And for the connections on the board, I'm just going to use these pin header connectors here, which I have, thankfully, with the matching tool. This is just a cheap one, but it does the job. So it's going to be another montage because there's no point in really going into detail. I'm just going to follow the wiring diagram. And I'm using some clear heat shrink tubing over the diode that we're going to have to put in here facing this way. And you want the ring of the diode facing towards our 555. I think the next step should be wiring our pot up here, or at least placing it in here so we can route the wires around it. Let's just put this in here. And then all the other connections are outwards facing connections, basically. So this is going to be wired up also according to this plan. So these 2 contacts are going to be wired up to our 555 timers PCB. The polarity of these doesn't matter as long as you hook them both up. This is just changing the resistance between these 2 pins on the PCB. Now it's a matter of connecting the wires from the cable to our directional switches and the rest of the wiring. And I like to do a check of the cable, even though these colors, the wire colors for joysticks, are somewhat standardized. Not too sure if that's the case with this cable. So I'm taking one of these connectors, putting it on our plug here and measuring which wire goes where, and I'm going to write the colors and the numbers down just to have it easier to follow the circuit diagram, soldering these all together and putting some heat shrink tubing over the wire connections that I'm just going to solder. This end is going to go in here and we're going to solder it in situ, I guess, but first of all we're going to figure out the pin out. And generally, if you're looking at these joystick plugs, this is how the pins are numbered from this side. 1, 2, 3, 4, 5 in the top row with more pins, and 6, 7, 8, 9. So these are the wire colors and the functions and the pin numbers for my cable that I have here. Your mileage may vary. This seems to be the common color coding for modern cables that you can buy these days. It doesn't match the color coding in the old joysticks like the Competition Pro or something like that. I'm going to wire this up with some heat shrink tubing over the contacts. It's going to be a bit of tedium. I am going to fold these over, the ones that are not connected, the brown and the yellow wire in this case, and put some heat shrink tubing over them in case we want to add a secondary fire button at some point or something like that. I'm not going to cut these wires, just going to fold them. And of course I'm going to use my shoddy crimp connectors on the micro switches. But I think I want to add a bit of solder to these because they're not made for small wires like these. I think we might have all the connections now. I'm going to put some cable ties in here once I have determined that this actually works. Which I guess is the next step before we do anything else. I'm just going to put one of these screws in here, I guess, so it holds together. And we're going to connect it to an old computer. So I had to make some minor corrections upon checking the schematics. I wired up and down the wrong way actually, and I put the 555 timer chip in there in the wrong position. So you always want to check everything again before you power something on. But now this should be wired up correctly. Time to find out. Let's see. Yeah. Okay, so we have our joystick buttons light up and we should be able to adjust this flashing here. This is our adjustable autofire. Yeah, we can adjust that with the potentiometer. Nice! Zeta Wing fired up here. Let's see if everything works. Left, right, up, down work. Autofire. And you can actually dial this in to whatever autofire speed the game needs or can handle. Okay, it works! And we should be able to switch the behavior of the lighting with our little switch in the back of the joystick. So at the moment this is flashing wildly, but we can just switch it off altogether and the joystick still works as it should. Even the autofire, it's just not flashing anymore. And we can make this solid. So this is just for the lights, the little switch in the back. Yeah, so I think the remaining bits are just fitting the feet on this, doing some proper wire routing inside this thing. So just some cable tying here. And I think I want this here. Yeah, we're going to put a nut in here. This works the same way as the counterpart on the other side there. And we can put this on here. A knob for our pod. Let's see. I found a pretty nice knob. Which is, I think, from a Bluetooth phone, car phone thing originally that I ripped apart. And it's a bit rubberized, like these early 2000s things. I think it matches the design of this quite well. So I'm just going to remove the protective film. Yeah. Yeah, it works really well. The autofire also works well. It's not really, that doesn't really make sense in Comic Bakery. But yeah, this is super nice. Feels good. Highly customizable, of course. It's a very cool joystick and it's all openly available. Yeah, I guess that's it for today. We successfully built this joystick and maybe this video is going to be helpful in case you try to do it yourself. I also recommend checking out the website at least, and also the Discord is there in case you want some support. Really cool project. Thank you for sending this to me, Frank, and thank you for your help, Discord. I'm going to have a lot of fun with this. Thank you very much for watching. Hope you enjoyed this little build. And as usual, special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or through single donations. The links to that are in the video description. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye. Did you know that shift lock actually pauses Giana Sisters? Oh, I don't have any fire. And this is not a good position.